Let's talk about something every developer wrestles with. How do we really know our code is solid? I mean, really, truly confident in it. It's not enough to just see that it runs without crashing. We need to know how much of its internal logic we've actually put to the test. Today, we're going to explore this by climbing what I like to call the code confidence ladder, where every step up gives us more and more certainty in the stuff we build.
You know the feeling. You write a new piece of code, you hit run, and success! No errors. Seems to work. And it's so tempting to just stop right there and call it a day. But that, my friends, is a classic trap. Just because your code works for one specific scenario doesn't mean it's robust. The real question is, how do we find all those hidden paths, all the little nooks and crannies in our logic that we might have missed?
Well, that's where this idea of structural testing comes in. Think of it as white box testing. Instead of just looking at the software from the outside like a user would, we're popping the hood. We're getting to peek inside the white box. We actually design our tests by looking directly at the source code, the if statements, the loops, all that raw logic. It's all about understanding the internal structure so we can test it properly.
So here's our game plan for climbing that ladder. First, we're going to peek inside the code's logic. Then we'll start climbing, level by level. We'll start with covering every statement, then move up to covering every decision, and then every single condition. And finally, we'll reach for the very top, the ultimate goal of covering every possible path.
Okay, let's get into it. Section 1. Inside the code's logic. Look, before we can even think about testing the structure, we've got to understand how it flows. This means we have to stop seeing our code as just a static wall of text and start seeing it for what it is, a network of pathways that our program can travel down.
The official term for this is control flow testing, and the goal is pretty straightforward. We want to identify all the possible routes or paths that your code can take from the moment it starts to the moment it ends. And how do we measure our success? Well, we use a metric called coverage. It gives us a hard number, a percentage, that tells us exactly how much of our code our tests have actually touched.
All right, we're ready. Let's take our first step onto the ladder. This is the most basic, the most fundamental level of coverage you can have, but it's an absolutely essential starting point. It's called statement coverage.
So, what's the deal with statement coverage? It's simple, really. The goal is to write just enough tests to make sure that every single line of executable code runs at least one time. Think about it. If a line of code is never, ever executed by any of your tests, it's a complete blind spot. You have literally no idea if it works or not. And what's kind of funny is how simple this can seem at first. For a really basic program that just runs straight through, you might only need a single test case to hit every single line from start to finish. And just like that, bam, you've got 100% statement coverage. Seems pretty easy, right?
But hold on a second. What if we only tested that one perfect, happy path where every single condition was true? What about all the other logical branches, the what-if scenarios? Sure, we've executed every line, but we haven't tested every possibility. And this, right here, is the huge weakness of relying only on statement coverage. And that glaring weakness brings us straight to the second rung on our ladder. It's time to level up. We have to move beyond just running every statement and start focusing on covering every single decision.
This next level is called branch coverage, or sometimes decision coverage. The goal here is a lot more ambitious. For every single if statement, every loop, every decision point in your code, you have to write tests that check both the true path and the false path. You have to go down both forks in the road, no exceptions.
So, if we want to get 100% branch coverage for our example code, that one test case just isn't going to cut it anymore. Our first test, you can see here, that covers the all-true path. But now we need a second test. We give it different inputs, and that forces one of our decisions to go down the false path instead. With just these two tests, we've now covered every single branch.
And this really highlights the key difference. Here's the most important takeaway. If you achieve 100% branch coverage, you have automatically achieved 100% statement coverage. It's literally impossible to test every outcome of a decision without running all the code inside those branches. This makes branch coverage a much, much stronger metric. It gives us way more confidence.
But we're not at the top yet. We're feeling pretty good, but there are still some sneaky little bugs that even branch coverage can miss. So let's climb again. We're moving up to level 3, covering every single condition.
Okay, this is where we really put our code under the microscope. See, a lot of times, a single decision is made up of multiple smaller conditions, right? Like, you might check if A is greater than B and A is greater than C.
Branch coverage only cares if that whole thing is true or false. Condition coverage says, nope, we have to dig deeper. We have to write tests that check the individual outcomes of A greater than B and A greater than C all on their own.
Think about how computers can be a little lazy. If you have a condition like this first thing and this second thing, and the computer sees that the first part is false, it often doesn't even bother to check the second part. It's called short-circuiting. It just says, well, the whole thing must be false, and moves on. That means our branch coverage tests might not have actually tested the logic in that second condition at all. Condition coverage fixes that. It forces us to test every single piece.
So to actually satisfy condition coverage, we need a whole suite of tests. We need to make sure every little subcondition has been true at some point and false at some point. If you look at this table, you can see it now takes 3 completely different test cases to fully exercise all the logic packed inside that one single if statement.
We've climbed from statements to branches to conditions. We're getting pretty high up now. And at the very top of the ladder, we find the theoretical peak of testing confidence. The holy grail. It's called path coverage.
The name really says it all. The goal here is to design test cases that execute every single possible path your code could take, from the very first line it runs to the very last. This is without a doubt the most comprehensive form of white box testing there is.
But, and this is a huge but, here comes the big reality check. As our source material puts it pretty bluntly, achieving 100% path coverage is often flat out impossible in any real-world program. The second you add just one simple loop, the number of possible paths your code can take can explode into the millions, billions, or even become infinite.
I mean, just look at our tiny little example program. It has no loops at all, and it still has 4 unique distinct paths from start to finish. To get full path coverage here, we'd need to write a specific test case for each of those 4 routes. That's doable. But now imagine a real program with dozens or hundreds of if statements. The number of paths becomes astronomical.
So let's just do a quick recap of our climb up the ladder. We started at the bottom with statement coverage, just making sure every line gets run. Then we climbed up to branch coverage, testing every true and false outcome. We got more granular with condition coverage, testing every little subpart of a decision. And finally, we reached the theoretical ideal at the top, path coverage, executing every possible route.
And this hierarchy shows exactly why path coverage is the ultimate goal. If you could somehow magically achieve 100% path coverage, you would, by definition, have already gotten 100% on every single level below it. It is the superset of everything. It's the whole shebang, offering the absolute highest level of confidence you can get. And that brings us to the final critical question. This is the one every software team on the planet has to answer for themselves. If perfect, 100% path coverage is basically a pipe dream, then what's good enough? We have to make a choice. We have to balance the confidence we get from more and more rigorous testing against the very real time and effort it takes to write all those tests. And finding the right answer to that question, that difficult trade-off, is right at the very heart of what it means to be a software engineer.